Here's another work problem. So we have a cable that weighs 2 pounds per foot attached to a bucket filled with coal that weighs 800 pounds. So the bucket is initially at the bottom of a 500-foot mine shaft. Okay, that should say shaft, not shift. Shaft. Determine the work required to lift the bucket all the way up the shaft. Okay, so there's a couple things that are going on here. The best way to start this problem is to draw a picture. So what I'm gonna have here is this bucket. So you have a bucket, and this bucket is full with coal. So there's coal in there, and it's attached to a cable. Oops. So you have some cable, and it's being lifted up. And we have a couple things. So we know that this entire, whoa, this entire distance is just going to be 500 feet. So that's 500 feet. And I'm lifting this whole entire thing up. So we want to figure out what is the work required to lift the bucket all the way up. So there's a couple things that are going on here because you need to be able to lift up two different things because we're not just lifting the bucket, we're also lifting the cable up. And the cable has also a particular weight, so it's not negligible. So if we look here, this cable weighs 2 pounds per foot. Okay, so we have some sort of weight for the cable, and for the bucket, we have that it weighs 800 pounds. Okay, so there's a couple things that we need to look out for. So we have two different forces. So I'm gonna write right here, we have two forces, or two weights. And the first thing is basically the weight of the cable. And then the other thing that we're lifting up is the weight of the coal. So we have two things that we're lifting up here. In order to do that, we need to figure out what these forces should be, because in order to do that, well, if I know the force of the cable, or the weight of the cable, and the weight of the coal, I can add these forces together, and then I can just find the work by taking the integral from a to b of the sum of the forces dx. So that's what I'm basically trying to do. So the first thing that we want to do is let's look at the weight for each individual one. So let's first start off with the weight of the coal, because that one's actually going to be the easiest. So let's start off with weight of coal. Okay, so the weight of the coal, if we go back up to the question, it says that the coal weighs 800 pounds. Okay, so that's just basically what it is. So the weight, which in this case, let me write weight with the whole word weight, is actually equal to the force, which is going to be 800 pounds. Now, why is this equal to the force? Because pounds is a unit of force, it's weight. Okay, so this, you don't need to multiply it by 9.81 because it's not mass. Okay, so this is the force that's being exerted from the coal. Okay, we're ignoring the bucket. All right, so that's the weight of the coal. That's the force for that one. And now let's look at the weight of the cable. Okay, so the weight of the cable. So in order to do this, let's go ahead and take one little piece, because what happens here is that when I start off and start pulling up the cable up to the top, notice that there's going to be less cable that I have to bring up. So now you have less weight that you have to continue carrying. So, and if you look here, they tell you that each piece of the weight of the cable weighs 2 pounds per foot. So every foot of this cable weighs 2 pounds. So I'm going to take one small piece of this. Okay, I'm going to take a small piece. And we're going to call this delta x. All right, now what I'm going to do is, because I'm lifting it up, notice that the distance so let's just say here is going to be 0. So notice that the distance here from here to here is going to be x units. Okay, so I'm lifting this up xi units. So if I wanted to lift it up from 0 to halfway, or from 0 to 25, or 0 to 150, whatever, I can be lifting it up. This is what xi is going to be. So if this is xi, this is how much I'm lifting. How much is left over? Well, what's left over is going to be what the total amount was, which was 500 Okay, so it's going to be 500 minus how much I'm lifting it up. Okay, so the weight of the cable is going to be changing. Okay, so the weight of the cable is going to be how much is left over times the mass. So how much mass is left over, or how much weight is left over? Well, we know that it's 2 pounds per foot. Okay, so we know that right now, let me just write down the force. We know right now it's 2 pounds per foot. Now, this is not the answer because this is saying that every 2 pounds of this cable, every foot of this cable is going to be 2 pounds. Now, how much am I lifting it up? So I'm lifting it up 50 minus XI units. So it's going to be 50, or not 50, 500 minus XI units. That's feet. Notice that the feet cancel out. So what I'm left with is just 2 times 500 minus XI. That is going to be the force as I'm changing XI. Okay, so this is how much and notice that it should actually be decreasing, because if I take XI here, you should have less and less of the cable. Now, could you have put XI the other direction? Yes, of course, you could have done it that way as well. If you wanted to change the XI and the 500 minus XI, you can switch them if you'd like. But then it will give you the same answer, but you'll see in the next problem why you might want to leave it like this. Okay, so now we have the forces. Now what we want to do is we want to calculate the work. Okay, so the work is going to be equal to the integral from A to B of the force due to the cable, let me write cable, plus the force due to the coal. Oops. Due to the coal, dx. Okay, so this is going to be, well, how far am I lifting it up? Well, I'm lifting it up from 0 all the way to the 500 feet. So it's going to be from 0 to 500. Okay, the force due to the cable is going to be 2 times 500 minus xi. Well, no more xi, it's just going to be x. Plus the force due to the coal, which is going to be 800. Is going to be dx. Okay, all right, so now let me go ahead and distribute this out. I'm going to have the integral from 0 to 500 of 1000 minus 2x plus 800 dx. This is equal to the integral from 0 to 500 of, this is going to give me 1800 minus 2x dx. Then I'm going to take the antiderivative. I'm going to get 1800x minus, this is going to be x squared over 2. The 2's cancel out, so I'm left with x squared from 0 to 500. And then I'm just going to plug them in. So I'm going to have 1800 times 500 minus 500 squared. And I'm going to ignore the 0 because it's going to go away. And what I'm going to be left with is 650,000. And in this case, what was the units? It's going to be feet pounds, I think. Yep, feet pounds. Okay, so this is the amount of work to lift all of this thing up. Okay, now a couple of things to know is that, of course, just like I said before, you could have interchanged these guys, and it's not going to change the answer. The integration is going to be a little bit different, but it's not going to change the answer. But you'll see why in the next video, why you might want to keep it this way. Okay, so that's it for this problem. We're going to do the next problem in a bit.